Hi class, this is section 6.2. We are going to be talking about circles, and we are going to have 5 conjectures in this lesson. So I would like for you to open up Sketchpad, and we are going to start with a circle. And what we are going to do is construct congruent chords. So to do that, I am going to highlight these 2 points, and I am going to construct a line, and then I am going to put 2 more points on the circle by making that intersection point and then another point anywhere. Then I'm going to highlight the center point and the point on the circle and construct another line. Oh, I didn't want all 3 of them. Okay, so the purpose of doing this is to make congruent chords. So the chords I am going to make by highlighting this point and constructing a segment. Remember, a chord is a line segment with both of its points on the circle. I'm going to highlight these 2 points and construct a segment. So now I have 2 segments, and I am going to go ahead and construct this as a segment. And then this is a segment so that I can hide my lines. Okay, so now I can move my points around, but what do you notice happens as I move this point around? You should notice that those 2 triangles stay congruent. They are congruent triangles no matter how I slide this point. So I am going to look at this central angle right here that has been made, and I'm going to measure it. Oh, I need to construct that as a point. Let's just highlight the 3 points, and I am going to measure the angle. Now it is vertical with this angle here. These are called central angles because the vertex lies on the circle. They're vertical. I know they're congruent. Then I want to measure segments AC and DE. They are the same. So we've got, and we know the radii are all congruent, so we have congruent triangles. Next, I want to measure the arcs. So I'm going to measure arc AC, highlight the circle, and notice it measures the same as the central angle, and it is going to be congruent to the one on the other side. So what happens here, if I have congruent chords, I am also going to have congruent central angles and congruent arcs. So I'm going to take my pen and I'm going to mark my congruent chords. That's what happens. If you have congruent chords, then you have congruent central angles. So let's go back to our conjectures. And fill in some information here. Okay, so conjecture 55, section 6.2. If 2 chords in a circle are congruent, then they determine 2 central angles that are congruent. Okay, so let's get that conjecture into your notes. And then the next conjecture as well. If two chords in a circle are congruent, then their intercepted arcs are congruent as well. So if you look at this picture here on this page, the angles are constructed congruent. They have congruent chords, so you have congruent central angles and then congruent arcs as well. Okay, so look for congruent chords in your circle pictures. The next conjecture we're going to talk about is perpendicular to a chord conjecture. So the perpendicular from the center of a circle to a chord is the blank of the chord. So let's see what happens if we construct a chord in a circle. So I'm just going to put another point on the circle. I'm going to highlight the 2 points and construct a segment, which makes a chord. Then I'm going to highlight the center point, and I am going to construct a perpendicular line, and I'm going to see what happens. So it intersects the chord. It's perpendicular to the chord. We know that because that's how we constructed it. But let's look at what else it does to the chord. So if I measure the distance between A and B, and then A and C, you notice that they are the same. So the length from B to A is the same as A to C. So if you have a chord and you perpendicularly bisect it with the diameter, or could just look at it as a radius. So you may want to make some markings there on your picture, but let's fill in our conjecture. The perpendicular from the center of a circle to a chord is the bisector of the chord. Okay, so our next conjecture, two congruent chords in a circle are blank from the center of the circle. So here's our, I'm going to go back to this picture that we started with. We have two congruent chords. Now, if I figure out the distance between the chord and the center, we should notice that they're the same. So let's see what happens. So I'm going to construct a perpendicular there, and then I'm going to construct a perpendicular to this side. It is the same in my picture. So I'm going to highlight this point and then highlight that point, and then I'm going to measure the length. So let's see. So from F to B we have 4.16. And from B to G we have 4.6. So when you have congruent chords, they are equidistant from the center of the circle when you have congruent chords. So let's go back and fill in our conjecture. The two congruent chords in a circle are equidistant from the center of the circle. Okay, then we have one more conjecture to look at today. Perpendicular bisector of a chord. The perpendicular bisector of a chord blank. So let's go and make a circle and see what happens. So I'm going to make a circle, and then I'm going to put a chord in it. So there is a chord. So the perpendicular bisector of a chord. So let's find the midpoint. And now make a line perpendicular to it. And what happens? It goes through the center of the circle. So no matter where I make my chord, the perpendicular bisector of that chord stays in the center of the circle. So the perpendicular bisector of a chord passes through the center of the circle, always. Okay, so there's your new conjectures for today. I'd like for you to look at these pictures right here, and I'd like for you to do numbers 1, 2, and 3 for class tomorrow. So do numbers 1, 2, and 3 for class, and I'll see you there.